Could you calculate this? What is this? What is this? And what is this? Alright, let's go. Hi, I'm Kadri. In this lesson, we are going to learn about geometric series. At the end of this lesson, we will be able to calculate geometric series of a given geometric sequence. Let's start. Okay, let us know about sequence. For example, you are given a sequence of 2, 4, 5, 2, 10, a sequence of 5 terms, and each term can be represented or noted by U1, U2, U3, U4, and U5. So this U1, U2, U3, U4, U5 is called sequence. Alright, so if we add them all so that we can have their sum, so we can have notation like this, a summation. So this is from Greek letter sigma. Alright, okay, so this represents the summation of all of these terms. So we can note that the summation of all term as the summation of all the un from n1 through n so this is 5. Okay, so we can say this summation, okay, is the sum of all un from n1 through n5. Alright, so this is the short form of the summation of all terms. Alright, from this example, okay, we can write the summation from n1 to 5 as a summation of all of 5 terms. If, for example, we want to choose only a part of it, okay, we can write, for example, from n2 to n4, so it has 3 terms only. Okay, and then if we start from 1 to 3, so we have 3 terms. Okay, so this can be represented by this summation notation. Alright, so that is the sequence and how we can write the summation of the sequence. Okay, next. Alright, we can have another special sequence. We call it as a geometric sequence. Okay, here we have so we have 1x, x square, x cube, and continues. So 1 is also equal to x power by 0 because anything is power by 0 is equal to 1. And x, if we don't put any power, it is already power by 1. Alright, so this sequence is called one of a type of we call as a geometric sequence. So in this geometric sequence, each of the following term is obtained from its previous term. Okay, so in the previous term, by multiplying with the common ratio x. That means x in the for example, if we take x power by 3, it is actually x power by 2 multiplied by x. So this is x multiplied by x. So we have x squared, and this is 1 multiplied by x. So we have a common ratio, and it is increasing sequence geometrically increase, we can say. Alright, so if we have this geometric sequence and we want to add them all, we would want to add all of the terms. So we can represent it by s, or equal to the summation. Okay, the equal of the summation of x power by n from n equal to 0 to n, capital N. So in this sequence, it contains n plus 1 terms, right? Okay, because if we expand this summation, it is equal to 1 plus x power by 1 plus x power by 2. So this is actually sorry, I got a mistake here. So this is wrong. So this is x power by 0 and this is none. Okay, sorry. Okay, so this is x power by 0 plus x power by 1, 2 and so on. So this is called a counting index. Okay, counting index. Okay, so it starts from 0 and then 1, 2 until the end. So so this geometric series, if we notated as this summation, so we notated as this summation, this is equal to 1 minus x power by n plus 1 over 1 over x. And x must not equal to 1, because if it is equal to 1, what will happen? It will be meaningless, because 1 minus 1 is 0, so it will go infinity. So the x will go to infinity. So this x must not be equal to 1. Okay, so how can we get into this? The summation is equal to this. How we get into it? Alright, so how do we reach to the formula? Alright, so once we expand, okay, I did mistake again. So this is, sorry, okay, I can make it, so we have to, sorry, so this is, so we can have either one, alright, but not both. Okay, that's why I make some correction here. So it should be 1 or x power by 0, but I just I choose 1 only, so I delete here. Okay, now we get the correct one. Okay, and this is also okay. Okay, and then from here we multiply by x. So in both sides we multiply by x, so we get xs. And then we multiply 1 multiplied by x, we have this. Okay, but I made also something wrong here, so this is correction, so we don't have this. So okay, so I just so we have like this, so this is wrong. Okay. Okay, then we have 1 plus 1 multiplied by x, we have x, and x power by 1 multiplied by x is 2, and so on. And lastly, x power by n, we multiply by x. Alright, so we get, for because we have x n, so if we multiply, we will get x n plus 1. Okay, so we have like this. So what we are going to do is that we subtract equation 1 from equation 2. That means equation 1 minus equation 2. So actually we can have all of the terms like this, these terms, and these terms all get rid of this subtraction. Okay, what remains is 1 and also x power by n plus 1. So that means 1, so we have 1. This is because we subtract equation 1 minus equation 2, then we have this is minus x power by n plus 1. So we have s minus x times s. So we have finally 2 terms remain. Others are cancelled out. Okay, then we can factorize s, so that we can get s multiplied by 1 minus x. We have the same thing again here, and then we put this below. Alright, so we put it under the fraction. Finally we get this expression, so that's why this is equal to the formula here. So we get the summation geometric series. So this is called a geometric series. This is also equal to this expression. All right. Okay, next. We return back by using this knowledge. We return back to our questions earlier to calculate this geometric series. Okay, so what we can do is that we can if we can expand, right, from 2x power by 0, okay, to 5, because the term is 5, so that means we have 5 plus 1, okay, plus 1. So this is, we can have n plus 0 to n. This is x power by n. So we make an equivalent between these two. So we can have then we have this summation. All right. So it has a 6 terms, right? By using our formula that we got in the previous slide, we have something like this. Okay, so this is we can simplify. Then we can have a 1 minus 2x. So this means this become x, and this k become small n, and this is n. So we make a equivalent between this formula and this formula. So we make a match. All right. So big N is 5. So k is equal to small n. The x itself is now 2x, and k is equal to small n. So we substitute into the formula. All right. So k plus 1 is 5 plus 1. So what we get is like this. Okay. So this question is that, is this equal to this? All right. So is it equal, this and this? It seems that this has a 6 term, but it is by using the formula we get this. So are they the same or not? So to test this questions, we let x equal to 1. Okay, we let the equal to 1 like this. So let's try the left side by putting 1 equal to 1 times 1, blah 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 blah. Okay, so you can get 63. Alright, so if you use this formula like this, we plug in x equal to 1, so we will get 63 too. That means we can trust this formula. Alright, we can trust this formula. It is okay if we have a small number of terms. We can add one by one. But if we have thousands terms, 2000 terms, so we need a formula. Alright, so that was about the geometry series. So we will maybe use it in the later for the probability and statistics at the end of this course. Alright, thank you. Bye.